Dear students, we are continuing to solve the April 2019 question paper, that is paper 2. So in the last class we have discussed about some problems regarding Boolean identity. So in this tutorial I will take up one problem, that is calculate the carrier swing carrier frequency deviation modulation index for an electromagnetic signal which reaches a maximum frequency of 99.047 megahertz and a minimum frequency of 99.023 megahertz. The frequency of modulation signal is 7 kilohertz. So in this problem, we will calculate the carrier swing, carrier frequency, frequency deviation, modulation index for EM signal which reaches maximum frequency. Means, say I am taking F1 as the maximum, then F1 is equal to, say it is actually the upper sideband frequency. So that upper sideband frequency is equal to 99.047 megahertz. Similarly, the lower sideband frequency, say you can write it as LSB, so which is equal to 99.023 megahertz. And similarly, the frequency of modulation signal, say that is FM is equal to 7 kilohertz. So we will calculate carrier swing frequency deviation. So first we can calculate the frequency deviation immediately, because frequency deviation, say delta F is equal to F1 minus F2. So F1 minus F2 means 99.047 minus 99.023 say megahertz. So which can be written as 0.024 7 minus 3 4 4 minus 2 2. So that megahertz, or you can say that 24 kilohertz we can write. So we are calculating here the frequency deviation. Then the carrier swing, another parameter we have to find out. Carrier swing is simply 2 times frequency deviation. So therefore the answer becomes simple, 2 into 24 kilohertz, or you can say that 48 kilohertz. So we have calculated frequency deviation and carrier swing. So then another one is modulation index. So in the case of modulation index, say MF is equal to delta F divided by FM, which means frequency deviation divided by frequency of the modulating signal. So delta F is equal to 24 kilohertz divided by this is 7 kilohertz. So that is, it is 24 by 7, which is 3.429. 3.429. Therefore, modulation index is 3.429. Then another one, carrier frequency. So carrier frequency is FC, which is equal to upper sideband frequency F1 plus lower sideband frequency F2 divided by 2. So upper sideband is 99.047 plus 99 F2.023, that much of megahertz divided by 2. So which is equal to 99.035 megahertz. So this is the answer. So we have calculated all the parameters which are asked in the problem. Then go to the 10-mark questions. So in the case of 10-mark question, the first question itself is state and prove De Morgan's first and second theorem with their truth table. So De Morgan's first and second theorem. So the De Morgan's first theorem tells us that complement of the sum is equal to product of the complements. Similarly, the second one, complement of the product is equal to sum of the complements. So these are the two theorems. Here we have to find out the truth table. So you can take A, B, then you can take A plus B bar. Similarly, you can take A bar dot B bar. So 0, 0, 0, 1, 1, 0, 1, 1. So these combinations you have to take and you have to find out the answers for this column as well as this column, and both columns will found to be same. So therefore it can be proved. So I think this is an easy question. So therefore there is no need to solve it again. So only with the help of the truth table. So you have to make LHS equal to RHS. Then another one, which is a long question, show that when a radio wave enters the ionosphere, phase velocity is greater than velocity of light. So here we have to show that the phase velocity is greater than the velocity of light in the case of when the radio wave enters through the ionosphere. So as far as the ionosphere is concerned, so you know that the earth has troposphere, stratosphere, then ionosphere. So the ionosphere extends from 50 km from the earth to 350 km. So its region is 50 to 350 kilometers from the earth, and the molecules are in the ionized state in the case of ionosphere, as its name suggests. So the state is ionized state. So when a radio wave, an electromagnetic wave, enters through the ionosphere, then N is the electron density. We have to consider capital N as electron density, that is the number of molecules per meter cube. So number of molecules per meter cube means number of electrons per meter cube in the case of ionosphere, and E is the minus E is the electronic charge, and m is the electronic mass. So then, in this case, the electric field is given by E is equal to E naught cos omega t. Say cosine function, so the E varies with the cosine function. I will say that E is equal to E naught cos omega t. So that is the electric field associated with the electromagnetic wave. So E is equal to E naught cos omega t. And therefore, what is the force acting on these electrons? So force is equal to minus E into E, because electric field intensity is equal to force per unit charge. So it is force divided by charge. So electric field intensity E is equal to force divided by charge. Therefore, force is equal to electric field intensity into charge. So electric field intensity into electronic charge, that is minus E. So therefore, F is equal to minus E, or the same can be written as minus E naught cos omega t. So this you can take it as equation 1. And also, if V is the velocity of the electrons, then m into dV upon dt, where m is the electronic mass, dV upon dt is standing for acceleration, because rate of change of velocity, so which is equal to the force. So what is the force? It is minus E naught cos omega t. So we have taken m, force F is equal to m into A form. So this is F, this is m, this is A. So therefore, I will take dV in the LHS, and other quantities I am moving it to the RHS. So minus E naught, say divided by m cos omega t into dt. So dV is equal to this quantity. So integrating. So integration of dV is equal to integration of minus E naught divided by m into cos omega t dt, or integration of dV is V itself. So V is equal to, say, minus E naught divided by m, is taken to be outside, integration of cos omega t dt. So minus E naught divided by m. So integration of cos omega t is sin omega t. Say sin omega t plus c divided by omega. So this divided by omega, I will write it here. Cos omega t, integrating, you will get sin omega t divided by omega, so that here denominator becomes m omega plus c. But here the constant c is taken to be 0. If you put the initial conditions, the constant c is going to be 0. Therefore, V is equal to minus E naught divided by m omega sin omega t. Say you can write it as equation 2. So you will get V is equal to minus E naught divided by m omega sin omega t. Then the electronic current density say J is equal to minus MeV. So this formula, I think it came in the first or second PUC itself, J is equal to minus NEV. So J is equal to minus NEV, which is equal to minus NE into substitute the value of E. Minus of E naught divided by M omega sin omega t. So or minus minus becomes plus N E square E naught divided by M omega sin omega t. So then, if we ignore the presence of electrons, then it is acting as a free space, ionosphere acting as a free space, and the displacement current density is given by say J displacement is equal to d by dt of epsilon naught E. So from electrostatics, the displacement current is given by epsilon naught E plus P, but here the polarization is 0, so that your displacement current is epsilon naught E, and displacement current density is differentiation of epsilon naught E. So or you can say d by dt of epsilon naught E naught cos omega t. So I have put E as E naught cos omega t. So it is equal to d by dt, say epsilon naught into E naught, and differentiation of cos omega t is minus sin omega t into omega, or minus omega epsilon naught E naught sin omega t. So therefore, the total current density is given by the total current density, say J total is equal to J plus JD. So what is J? N E square E naught divided by M omega into sin omega t plus JD is plus means here minus omega epsilon naught E naught sin omega t. So again we can simplify it also. So E naught sin omega t is common. So I am taking this one as the first term, minus omega epsilon naught E naught sin omega t plus N E square E naught divided by M omega sin omega t. Then I will take up
E naught sin omega t
minus omega outside, E naught sin omega t also outside. Then here I will get minus omega, means here epsilon naught, plus N E square divided by M omega square.
Correct.
So therefore, again I will take minus omega epsilon naught. I will divide by epsilon naught here. Epsilon naught divided by epsilon naught is 1. And of course, sorry, this is minus, because I have taken minus omega, so that here it becomes minus. So 1 minus N E square divided by M omega square epsilon naught into E naught sin omega t. Or I will take minus omega epsilon into E naught sin omega t. say equation 3, where this epsilon is written as
epsilon naught into epsilon naught
epsilon naught
into bracket
1 minus n e square divided by m omega square epsilon naught. So equation 4 you can write. Or epsilon divided by epsilon naught, you can take 1 minus n e square divided by m omega square epsilon naught. So epsilon divided by epsilon naught is equal to 1 minus n e square divided by m omega square epsilon naught, or 1 minus. So n is the electron density in the ionosphere. It varies. E is the electronic charge, which is a constant. M is the electronic mass, which is a constant. Omega is 2 pi f, so f varies. Epsilon naught is a constant. If you put all the constants in the equation, then it is 81n divided by f square. Here I have taken omega is equal to 2 pi f, where 2 pi is a constant. So if you evaluate this term, it is going to be 81n divided by f square, which is epsilon divided by epsilon naught. But note that epsilon is less than epsilon naught. Epsilon is less than epsilon naught, because in the ionosphere epsilon is less than epsilon naught, while mu is equal to mu naught. So electric permittivity is less, but magnetic permeability is the same. So in the case of vacuum or air, and compared with the ionosphere. So then the phase velocity is given by in a given medium is equal to 1 divided by mu epsilon. So this is a standard equation, velocity of an electromagnetic wave, which is V is equal to 1 divided by square root of mu into epsilon.